Today we are going to talk about what happens to mass in a chemical reaction. We need to be aware of a couple of things. Now this is part 4.313, mass changes when a reactant or a product is a gas. Okay, so let's go straight into an example. So this is a thermal decomposition of a metal carbonate. In this case it's copper. Thermal decomposition basically means therm is just heat, decomposing something is breaking it down. So we're using heat to break down this substance, which is a metal carbonate. Okay, now from this diagram you can see that heat is applied, okay, from here to the copper carbonate. A chemical reaction occurs, the decomposition occurs, okay, there's some releasing of carbon dioxide. Okay, now the key thing you need to know is this is not an enclosed system. What does that mean? Enclosed basically what it just means that the gas can escape in the reaction. Okay, enough energy is supplied via heat, it breaks down the substance, carbon dioxide is released. Now the key thing here is the mass is going to change. So let's say, for example, we had 10 grams of copper carbonate. After the reaction has occurred, the decomposition has occurred, it may well be that it's 8.4 grams of copper oxide formed. That's because the carbon dioxide has escaped, okay, because it's not an enclosed system. So the key thing you need to know is when it's not an enclosed system, the gas will escape, okay, if there is a gas produced, and the mass will reduce. You can still account for it because of the conservation of mass. We know this gas has escaped, but we need to understand and explain that. So let's look at another scenario where we're doing the same thing, okay, but this time we've sealed the system here and we are collecting the actual gas. The gas is going up this column and into our lime water. The lime water is turning cloudy, and this is evidence that carbon dioxide is produced. But if this system here was also sealed, okay, right, the total mass of this and this would equal the original mass of carbon or copper carbonate, I should say, right? So that's essentially it. If it was a sealed system, the mass would be the same for the reactants and the products, but this is not a sealed system, so the mass will change, it will reduce. So keywords: enclosed system, sealed system, collecting gas, and this is the test for carbon dioxide here. We bubble it into lime water. If it turns cloudy, that's a positive test for carbon dioxide. Okay, moving on, let's look at an exam question and practice what we're preaching here. Okay, so here we have a setup. There's 10 grams of a metal carbonate. It doesn't say which one here because we've got 4 different types. We're doing the same process. As you can see, it's bubbled into lime water. It's not a sealed system because there's no sealing here. That means the gas escapes if a reaction occurs. Okay, then we've got some figures in a table. We've got copper carbonate, magnesium carbonate, potassium carbonate, zinc carbonate. You can see the mass after heating for 5 minutes and observations. The question is a 3-marker. It's asking what would happen or explain the results for potassium carbonate. You can pause it there and try answering this question yourselves now before I give you the answers. Okay, so explain the results for what happens to potassium carbonate. As I look at all these results, there's been a mass change there. I tick it, there's been a mass change there. This has stayed the same. I'm putting an X on there. So that means, without me even looking at the observations column, we know a gas has been released from our knowledge, and it's not an enclosed system, so the gas has actually escaped during this thermal decomposition. So there you go, more gases escape there, less here, and somewhere in between there. Now the test proved that lime water turns cloudy. We know it's carbon dioxide. Positive test, negative test, positive test. So explain the results for potassium carbonate. So for 3 marks, the first thing I would say, okay, number 1, I would say no reaction has occurred. No reaction. And we need to explain why. Maybe because not enough energy supplied. Okay, so more heat is required. Number 2, right? So how can we explain the results? So we can say that mass has not changed. This means no carbon dioxide released. So for the 3rd mark, we would say hence a negative test for CO2. And you can see the lime water not cloudy. Okay, and there you go, that's your 3 marks. Now hopefully that makes a bit of sense. Just to summarize in a nutshell, you need to know that if thermal decomposition occurs or there's a chemical reaction where a gas is released, that means the products, the mass is going to be less because the gas is escaped into the atmosphere if it's not an enclosed system, it's an open system. Okay, over and out, and I'll see you in the next one.